everyone, this is Kalpana here. In this video, we are going to prove the statement using principle of mathematical induction. So let's get started. Problem. Using the principle of mathematical induction, prove that 1 square plus 2 square plus 3 square plus so on plus n square equals to 1 by 6 into n into n plus 1 into 2n plus 1 for all n belongs to natural numbers. So we have given the statement. We have to show that, we are asked to show that the statement is true for all n belongs to n using principle of mathematical induction. Okay. Solution. Let P of n be the given statement. Then P of n such that 1 square, first term, second term, third term, plus so on, plus nth term equals to RHS. Okay. So we are given n terms in the LHS, right? So let's consider or let's represent the first term by T1, second term by T2, third term by T3 and nth term by Tn. Okay. So we are having nth term Tn equals to n square, right? If this is your nth term, what will be the kth term? Simply Tk equals to k square. Okay. Let it be. If you substitute n equals to 1 in Tn, you have to get 1 square, that is first term. When you substitute n equals to 2, 2 square, you'll get 2 square, which is your second term. Likewise, when n equals to 4, you'll get 4 square. This will be your fourth term. Likewise, when n equals to 3, you'll get 3 square, which is your third term, right? Likewise, when n equals to k plus 1, you'll get k plus 1 whole square. This will be your k plus 1th term. Okay, fine. So here we have to show that the statement is true for n equals to 1, and we'll assume that the statement is true for some k which belongs to natural numbers, and finally we'll show that the statement is true for k plus 1 using P of k. Okay, fine. When n equals to 1, from LHS we'll take only the first term since we are asked to show for n equals to 1. Okay, we'll only take the first term. If we are asked to prove for n equals to 2, we'll simply take the sum of 2 terms. When n equals to 3, we'll take the sum of 3 terms. Likewise, when n equals to 4, we'll take the first 4 terms. The sum of first 4 terms. Okay. We are given the sum of n terms here in the statement. Okay. Alright. Now coming to LHS, we'll get only the first term 1 square, which is equals to 1. Now coming to RHS, simply substitute n equals to 1. This is equals to 1 by 6 into 1 into 1 plus 1, 2 into 2. 2 ones are 2. 2 plus 1, 3. 2 ones are 2 threes are 3 ones are 3. 3 ones are 3 threes are. So this is equals to 1. So here LHS equals to RHS. Therefore LHS equals to RHS. From this we can say that P of n is true for n equals to 1. Therefore, P of 1 is true. Okay. Likewise, we can show for n equals to 2. We can show that the statement is true for n equals to 2. Let's check for n equals to 3. Okay. When n equals to 3, you have to take the sum of first 3 terms. 1 square plus 2 square plus 3 square. While considering LHS, you'll take the sum of first 3 terms is equals to 1 plus 2 square is 4 plus 3 square is 9. So 9 plus 1 is 10, 10 plus 4, 14. Okay. Now coming to RHS, simply substitute n equals to 3. Three ones are 3 twos are 1 by 2 into 3 plus 1 4 into 3 twos are 6, 6 plus 1 7. 2 ones are 2 twos are 2 sevens are 14. So here LHS equals to RHS. So from this we can say that P of n is true for n equals to 3. Therefore, P of 3 is true. Okay. If we want to check for n equals to 2, from LHS we'll take sum of the first two terms, and while coming to RHS we will simply substitute n equals to 2. Okay. Fine. Now, assume that P of n is true for some k belongs to natural numbers. Then P of k such that first term, second term, plus third term, plus so on, plus how we'll get kth term? By substituting n equals to k. Equals to 1 by 6 into k plus 1 into 2k plus 1. The sum of k terms equals to RHS. Okay? Fine. Since P of k is true, using this we can show that P of k plus 1 is true. Okay? Now, P of k plus 1 equals to, consider sum of k plus 1 terms, first term, second term, third term, plus so on, plus kth term, plus k plus 1th term. Okay? By substituting n equals to, this is the nth term, right? By substituting n equals to k plus 1, you'll get kth term. You substitute k, n equals to k in nth term, you'll get kth term. If you substitute k plus 1 in the nth term, you'll get k plus 1th term. Okay, fine. So this is equals to, we are having the sum of k terms equals to 1 by 6 into k plus 1 into 2k plus 1. Okay, plus the last term will be as it is. Okay. See, we have to get 1 by 6 k, for n equals to k plus 1 in the RHS. Okay. So you have to get 1 by 6 in the RHS. So what we'll do is, we'll take 1 by 6 into k plus 1 common. You're having k plus 1 in both the terms, okay? Since we need 1 by 6 here to get RHS, so we'll take 1 by 6 and k plus 1 common. For that purpose, what we'll do is, we don't have any 1 by 6 in the second term, right? For that purpose, we'll multiply and divide 6 to the second term. Since 6 by 6 is 1, which is equals to k plus 1 whole square, right? This is equals to k plus 1 whole square, right? Now it's easy to take 1 by 6 and k plus 1 common from these two terms. This is equals to 1 by 6 into k plus 1 into k into 2k plus 1 plus 6 into, you'll get 1k plus 1 here. Okay. So this is equals to 1 by 6 into k plus 1 into 2k into k is 2k square plus 1 into k plus 6k plus 6 ones are 6. So this is equals to 1 by 6 into k plus 1 into 2k square plus k plus 6k is 7k plus 6. This is equals to 1 by 6 into k plus 1 into 2k square plus split this 7k as 4k plus 3k plus 6. This is equals to 1 by 6 into k plus 1 into, now take 2k common from the first two terms, you'll get 2k times k, 2k into k, 2k square plus 2. 2k into 2 is 4k plus, take 3 common from the next two terms. You'll get 3 times k plus 2. 3 into k, 3k plus 3 2s are 6. Okay. So this equals to 1 by 6 into k plus 1 into, since k plus 2 common, you're having k plus 2 in both the terms. So take k plus 2 common from these two terms. Then you get k plus 2 times 2k plus 3. Which is equals to 1 by 6 into k plus 1 into k plus 2 into 2k plus 3. Okay. So here we have to get everything in terms of k plus 1. Okay. Fine. So this is equals to 1 by 6, first one, into k plus 1 for n equals to k plus 1. So you need to change this 2 in terms of k plus 1. So what I can do is, we'll split this 2 in as 1 plus 1, so that you can consider k plus 1 as one number, okay, which belongs to rational numbers, into, you're having 2k plus 3, right? You're having 2k, that means you'll get something like this, 2k plus 1. We have 2k plus 1 equals to, we'll get 2k plus 1 equals to 2 into k, 2k plus 2 into 1, 2. So when we'll get 3 by adding 1 to this 2. That is, we have to add 1 to this number to get 3. See, 2k, this equals 2k plus 2 plus 1, 3. Okay. So now you can replace 2k plus 3 by 2 times k plus 1 plus 1, which is the same number. Okay. So we'll replace 2k plus 3 by 2 times k plus 1 plus 1. So now we are having everything in terms of k plus 1, right? 1 by 6 into n plus 1 into 2n plus 1. This shows that the RHS is true for n equals to k plus 1. This is your LHS, which is your RHS. We have considered LHS. From this we got RHS. Okay. This shows that P of k plus 1 is true. Therefore, P of k plus 1 such that 1 square plus 2 square plus 3 square plus so on plus k square plus k plus 1 term, k plus 1 square equals to 1 by 6 into k plus 1 into k plus 1 plus 1 into 2 times k plus 1 plus 1. Okay. So the given statement is true for n equals to k plus 1. Okay. Therefore, P of k plus 1 is true whenever P of k is true. Thus, P of 1 is true and P of k plus 1 is true whenever P of k is true. Therefore, by the principle of mathematical induction, the given statement of P of n is true for all n belongs to natural numbers. This completes the problem. So we have seen a problem from mathematical induction in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.